Okay, good day. For today, our discussion is about the propositional logic. So, the previous unit discussed the highlights and manifestations of mathematics in our physical environment. Mathematics speaks to us through various forms and patterns found in nature. In this unit, we shall learn how mathematics speaks to us, not just only with numbers and symbols, but also with English statements. Okay, we shall connect statements with mathematics by translating them into symbols and by applying rules and laws. Also, let us formulate the primary considerations in determining whether a set of symbolic logic is true or false. Okay, so for today, what are our objectives? At the end of the discussion, at the end of the lesson, you should be able to first use symbols in expressing logical statements. Second, construct simple statements and compound statements and transform in symbolic form. Third, construct a truth table and identify its truth values. Fourth, translate an argument into logical notation of propositional functions. And that's it. Okay, so for today, let's try to discuss about the propositional logic. But before that, let's have the formal definition. Okay, the formal definition of the logic. Okay, logic is known as the study of language and reasoning. It is specifically concerned with whether the reasoning is correct, and its focus is more on the relationship among statements rather than the content of any particular statement. So take note, later we're going to observe different statements. Okay, we're going to deal with the English language. We're going to utilize that, and we're going to represent those statements with a symbol. Okay, so for today we have that as our lesson, the propositional logic. Now, since we are dealing with propositions or known as the statements, let's have its definition. Okay, so proposition is also known as statement. It is a sentence that is either true or false, but not both. Okay, remember, it should be true or false, but not both. Okay, it's typically expressed as declarative sentence as opposed to a question, command, and so on. So it should be declarative. It should not be interrogative or imperative sentence. Okay, and since we are dealing with the symbolic logic, we're going to represent it with a symbol. Okay, we use variables or letters such as P, Q, R, S, and T to symbolize those propositions. So basically, we're going to use the lowercase letters of an English alphabet to represent those simple statements. Okay? So now let's have an example. Okay, so as you can see here in our definition, it has two requirements. The sentence should be true or false only. And at the same time, it should be a declarative sentence. Okay, so let's have an example. Okay, so we have here example number one. Sara Duterte is the current Vice President of the Republic of the Philippines. An angle measured exactly 180 degrees is a straight angle. The product of 8 and 10 is 18. And lastly, 9 minus 5 is equal to 6. So as you can see here, one of the requirement, it should be in declarative form. So as you can see here, all statements here is in declarative sentence. So another requirement, it should be true or false only. Okay, so let's try to identify the truth value of each proposition here. So number one, Sara Duterte is the current Vice President of the Republic of the Philippines. So obviously this is true. So whenever we have propositions and identifying its truth value, we represent true as capital T and false as for capital F. Okay, false capital F. Another statement, an angle measure exactly 180 degrees is a straight angle. So here it's also true. Okay, so capital T. Another one, the product of 8 and 10 is 18. Okay, the product of 8 and 10 is 18. So the truth value here is false. Okay, so it's capital F. Because the product of 8 and 10 is obviously that's 80, not 18. Okay, the next one we have here 9 minus 5 is equal to 6. Okay, so 9 minus 5 is equal to 6. So obviously this is a false proposition. Okay, because the difference between 9 and 5 is 4. Okay, so as you can see here, we meet the two requirements that it should be in declarative form, and at the same time, it can be identified as true or false, but not both. Now, I'll present some examples of not a proposition, and let's try to determine why is it not a proposition. So let's have this first statement. Why are you studying? Okay, why are you studying? So as you can see here, statement number one, it's in a form of interrogative. It's in the question form. So therefore, this is not a proposition. Number two, come to class. I come to class. So as you can see here, it's in the form of command. Okay, it's in the form of command. So it's not a proposition also. Next one, 6x minus 9 is equal to 36. Okay, 6x minus 9 is equal to 36. So, this one is not a proposition because there's no specific value of x. Okay, there's no specific value of x. So, let's try to revise it so that this is, we can consider this as a proposition. So, we can have the statement, if x is equal to 3, then 6x minus 9 equals 36. Okay, so as you can see here in the previews, it's just an equation. You don't have any value of x. So therefore, you can't identify its truth value. Okay, but in here, if we're going to look at this, we put a value of x. And here we can identify that this is a false proposition. Okay, so if x equals 3, then 6x minus 9 equals 36. So if we're going to solve for the value of x, it's not 3. Okay, it's 45 over 6. Okay, so as you can see, it's not 3. So therefore, we can identify that that is a false proposition. As you can see, this is not a proposition, but this one is. Okay, because we have the value of x. So we should be specific. Okay, we should be specific. Number 4, students are excited to learn mathematics in the modern world. Okay, students are excited to learn mathematics in the modern world. So as you can see here, we have here uh, the subject students. Okay, we have the subject here students. So since it's students, it may vary, right? It may vary. It could be one student is excited to learn mathematics in the modern world and the other one's not. So as you can see here, the subject here is not appropriate for the proposition. So what should we do? Okay, we should put a singular pronoun or it could be proper or improper. Okay, it could be proper and improper, but we should be specific. Okay, we should be specific. For instance, we have here Sheldon is excited to learn mathematics in the modern world. So as you can see here, you can identify this whether it is a true or a false proposition because it is specific. Unlike with here, students. Okay, answer may vary. It could be true or false. Okay, so remember that. Okay, you should be specific. You can use a singular pronoun whether it is a proper or improper pronoun. Okay? And also, uh, if it is a plural, we will discuss it in the next part of our discussion. We will use a quantifier so that we can identify, we can describe the collective or the people involved there and its quantity. Okay, so later let's discuss that if the subject is plural. Okay, so let's have an activity. Okay, let's have an activity. Let's try to determine whether the given sentence is a proposition or not. Okay, so number one, find a number which divides your age. Okay, find a number which divides your age. So clearly, this one is not a proposition. Okay? It's not a proposition. So as you can see here, it's in the form of command. Okay? It's in the form of command. So therefore, this is not a proposition. So let me present the other statements. The other sentence here. Okay, so again, number one, it's not a proposition. Okay, how about number two? Given that a function is equal to square root of x all over x plus 1 is a rational function. So you try this. You can pause if you want to think about this. Okay? But the answer here is it's a false proposition. Okay? It's a proposition. Okay? There's an example here of a function and we determine what type of function is that. Okay, so in this case, we have square root of x over x plus 1, which is not a rational function because we have here a variable that is inside a radical symbol. Okay, so if that's the case, again, by the definition, rational should be a ratio of two polynomial functions. So therefore, this is a false proposition. Number three, if you are more than 6 years old, then you are entitled to a senior citizen's card. And if you are entitled to a senior citizen's card, then you are more than 60 years old. Okay, this one is a true proposition. Okay, this is a true proposition. Why? If you're going to look at this, it's a fact. Okay, it's supported by a law that if you are more than 6 years old, then you are entitled to have those that senior citizens card. And vice versa, if you have that senior citizens card, obviously you are more than 6 years old. Okay, your age is more than 6 years old. So therefore, this is a true proposition. Then lastly, number four, my seatmate will get a perfect score in the logic exam. So try to think about this. Okay, then this one, number four, this is a proposition, but it is under investigation. Okay, it's a proposition under investigation. So as you can see here, we have my seatmate as our subject. So it's individual, it's singular. So therefore, here, with this statement, we can identify whether it is true or false. Okay, but again, this is under investigation because we're going to wait, okay, for the examination of the logic, okay, to happen so that we can identify for that seatmate if that seatmate will get a perfect score or not. Okay, so again, you can use singular noun pronoun. It could be proper or improper. Okay. Now, let's identify the types of propositions or the statement. We can identify that as simple or compound proposition. A simple proposition, like in English class, it could be simple or compound. The same idea, simple statement is one that does not contain any other statements as a component part. Whereas the every compound statements or proposition does. Okay, so let's go back to the previous slide. Example number 2 and number 4 is a simple proposition. Okay, it's a simple proposition. While example number 3, we have here compound propositions. If we're going to look at this, we have connectives here. Okay, we have the if, and then we have the then, we have and. Okay, in the statement. Okay, it's more than one simple proposition. So again, simple proposition is a proposition that can be written with symbols with the use of single variable. While compound proposition is the result of combining simple propositions or producing new propositions from existing proposition. Now, let's explore. Okay, let's explore the compound proposition. Let's try to identify what are the connectives used, okay, for us to have those compound propositions. Okay, so we have the connectives, okay? We have the connectives negation, conjunction, disjunction, conditional, and biconditional. Okay, we have here the keywords to use For negation, we have the not. For conjunction, we use the word and other conjunctions in English, okay, such as but, while, yet, and so on. And we have here the disjunction or. Okay, for the disjunction, the only keyword here is or, either or. Okay, we can use the word either also. And then for the conditional, we have if then. Okay, we have if and we have then. If then. And then for biconditional, we use if and only if. We use the phrase if and only if. And our symbol for the negation is here, this one. For the conjunction, we have the inverted V. For the disjunction, we have the V symbol. For the conditional, we have one-headed arrow. While for the biconditional, we have two-headed arrow. Okay, so let's discuss it one by one, starting with the negation. Okay, so given a proposition P, the statement that says not P is a proposition known as the negation of P. This proposition is true if and only if P is false and is denoted by this. Okay, so now let's have an example. We have proposition P, I am reading a book. And if we're going to have the negation, we have I am not reading a book. Okay, I am not reading a book. Okay, let's have another. 3 plus 4 is equal to 8. Okay, 3 plus 4 is equal to 8. So, what's the negation of that? 3 plus 4 is not equal to 8. Okay, 3 plus 4 is not equal to 8. Next one, human needs companionship. Human does not need companionship. Another one, a statement can be simple or compound. A statement cannot or can't be simple or compound. Okay, so what about the truth value? Okay, what about the truth value here? So, as you can see here, we only have one proposition. Okay, we have simple proposition here. And if we have one simple statement or one simple proposition, we only have two cases. It's either the proposition is true or the proposition is false. Okay, it's either true or false. Now, if we're going to negate that, as you can see, the truth value is reversed. So, if the proposition P is true, its negation is false. Okay, its negation is false. And if the proposition P is false, its negation is true. Okay, its negation is true. So, for instance, let's have this number 2. So, given that we have 3 plus 4 is equal to 8, and if we're going to identify the truth value, this is false. Right? 3 plus 4 is equal to 8. That is a false proposition. Obviously, 3 plus 4 is equal to 7. And then, if we're going to have the negation, 3 plus 4 is not equal to 8. So, obviously, this is true. Right? This is true. Because 3 plus 4 is not equal to 8. Because, again, 3 plus 4 is equal to 7. Okay? So, as you can see here, again, you're just going to reverse. If you have the negation, you're just going to reverse its truth value. Okay, let's have the connectives for the compound propositions, starting with the conjunction. Okay, starting with the conjunction. So, given the propositions P and Q, the statement P and Q is a proposition known as the conjunction of P and Q. This proposition is true if and only if P and Q are both true. Okay, P and Q are both true. So, remember that. Okay, both statements should be true. Okay, so for us to consider, it's the truth value of that to become true. Okay, and we denote it with inverted V. For instance, we have proposition P and now we have proposition Q. Okay, it's cold in the room. I forgot to bring my jacket. So if we're going to have the conjunction, it is cold in the room and I forgot to bring my jacket. Okay, so here in our illustration, we only limit it by two simple propositions, but you can have three or more, okay, to have the conjunction. And still, the requirement is all should be true, okay, for that to become true. Another example, Tony is watching a movie. Tony is eating popcorn. So if we're going to have the conjunction, Tony is watching a movie while eating popcorn. Tony is watching a movie while eating popcorn. Okay, so now, let's try to identify its truth value. So as you can see here, we have two simple propositions. Since we have two simple propositions here, there are four cases to deal with. Okay, there are four cases to deal with. Okay, the first case here, if both are true, okay, if the both simple propositions are true, then we can say that it is true. Okay, the conjunction of the two simple proposition is true. Okay, and then we have here, if we have P as true and Q as false, obviously that is false. Okay, and vice versa, if P is false and Q is true, that's still false. And both are false, then that is false. Okay, again, the requirement, if you have the conjunction, both should be true. Okay, both should be true. So take note of this. Okay, take note of this because later we're going to utilize this for the construction of the truth tables. Okay. Next one, we have the disjunction. Okay, so given that we have the disjunction, we have or. Okay, we have or. Okay, unlike with the conjunction, again, we use the word and, we use the word while, yet, but here in disjunction, the only word, the keyword that we're going to use is or. Okay, we have either or just or. Okay? And its truth value, what about its truth value? The truth value here is it is true if and only if at least one, okay, at least one of the simple proposition is true, then we can consider that as true. Okay, so again, if one is true, at least one is true, then we can consider the disjunction of the statements as true. So, an example, you will play Mobile Legends, you will study your lesson. Okay, so the disjunction of that, we have you will play Mobile Legends or study your lesson. There one, the Philippine government shall focus on agricultural sector. The farmers will die poor. So if we're going to have the disjunction, the Philippine government shall focus on agricultural sector or the farmers will die poor. So again, since we have two simple propositions here, we have four cases. Again, for this to become true, at least one of the simple proposition is true. So as you can see in the first, second, and the third row, the third three cases here, the proposition is true. Okay, so here we have both are true, so that's true. And we have P as true and Q as false, so obviously that's true because we one uh, simple proposition as true. And then we have here false for P and then Q as true, so obviously that's true. And the only time that this will become false when both are false. When both are false. Okay. And again, the same with the conjunction, it could have three or more simple propositions. Okay. And same rule. Okay. Same rule for the truth value. Next one, the conditional proposition. What about the conditional proposition? Here in the conditional proposition, if P then Q is known as conditional proposition, we have the terms to use for P and Q. Okay, P is called as the premise, hypothesis, or antecedent. Okay, while Q is known as the consequent or conclusion. Okay, but for us to have the uniform term to use, let's use for the P as for the premise and then Q as for the conclusion. Okay, so this is the premise and this is the conclusion. Okay, so premise, then conclusion. Okay, premise, then conclusion. Okay, so remember our discussion last time. We have the term premise, tinuturo si conclusion. Okay, premise, tinuturo si conclusion. Okay, so now, we also have its condition. So there's only one case, okay, for the conditional proposition to become false, only when the premise is true and the conclusion is false. Okay, so take note of that. Okay, there's only one case Okay, for this to become false. When the premise is true and the conclusion is false. Let's have an example. The Philippine government focuses on agriculture sector. No Filipino farmer screaming for help today. So if the Philippine government focuses on agriculture sector, then no Filipino farmer will be screaming for help today. So we have the premise here, and then we have the conclusion. Another example. You wear a face mask every time you go outside, you have a lower chance to be infected with COVID-19. Okay, so if we're going to have its conditional proposition, if you wear a face mask every time you go outside, then you will have a lower chance to be infected with COVID-19. So here we have now the truth values. Okay, so again, if we're going to go back to the previous slide, there's only one condition that this conditional proposition to become false. When the premise is true and the conclusion is false. Okay, so this is false. Okay, there's only one case. Okay, and the rest is true. When the premise is true and the conclusion is true, that is true. Okay? When the premise is false and the conclusion is true, still true. And when the premise is false and the conclusion is true, still true. Okay, so again, there's only one case. When the premise is true and the conclusion is false, then it is false. So remember that. Okay, there's only one case for the conditional proposition. Again, when the premise is true and the conclusion is false, then it is false. Okay, so take note of that. Now, when it comes to conditional proposition, take note that there are different forms of conditional propositions. We can have its converse, wherein we're going to interchange, okay, the premise and the conclusion. Okay? Okay, we're going to interchange the premise and the conclusion. While here, another one, we have the inverse, wherein we have the negation of the premise and the conclusion. We're not going to interchange them, but we're going to negate them. And then lastly, we have the contrapositive. In contrapositive here, take note that we're going to interchange the premise and the conclusion, and at the same time, we're going to negate that. We're going to negate that. Okay? Okay, so we have here the conditional proposition. If you live in Malinta, then you live in Valenzuela City. Okay, if you live in Malinta, then you live in Valenzuela City. Okay, so now, what about its converse? For the converse, we have this. Okay, we're just going to interchange the premise and the conclusion. If you live in Valenzuela City, then you live in Malinta. Okay, we're just going to interchange the premise and the conclusion. And then for the inverse, we're just going to negate the conditional propositions for the premise and the conclusion. So here, if you're not living in Malinta, then you're not living in Valenzuela City. So as you can see here, from the conditional proposition, we just negate the premise and the conclusion. So here we have, if you're not living in Malinta, then you're not living in Valenzuela City. Okay, lastly, we have contrapositive. For the contrapositive, we're going to interchange the premise and the conclusion. And at the same time, we're going to negate them. Okay, we're going to negate them. So we have here, if you're not living in Valenzuela City, then you're not living in Malinta. Okay, so if you're not living in Valenzuela City, then you're not living in Malinta. So as you can see, we interchange the premise and the conclusion, and at the same time, we negate them. Okay? Now, here when it comes to its different forms, take note that there are logical equivalents to its statements, such as the conditional proposition has the same truth value for the contrapositive. Okay, so the three lines here, it means logically equivalent. Okay, it means logically equivalent. Meaning, if your conditional proposition is true, then your contrapositive also is true. If your conditional proposition is false, then the contrapositive of that statement is also false. Same with the converse and inverse. Okay, so if the converse is true, then the inverse of that statement is true. If the converse is false, then the inverse is also false. Okay, that is, they are logically equivalent. Okay, so take note of that. And then lastly, we can also have the logical equivalence of the conditional proposition given that we have the disjunction. Okay, its form, if we have the disjunction, we have negation of P or Q. Okay, so again, this conditional proposition is the same as negation of P or Q. Okay, so take note of this. Take note of this logical equivalence because we can utilize this when it comes to identifying the truth values. Okay, given the assumptions. Okay, given the assumptions. Okay, so take note of that. Now, let's proceed to the last one. Okay, last connective. If P and Q are propositions, the statement P if and only if Q is called as biconditional proposition. Okay, so we have here again the statement that the conditional proposition is true if and only if they have the same truth values. Okay, if they have the same truth values. Okay, so if P is true, then Q should be true. So that the condition biconditional proposition is true. So as you can see here, it's a combination of all the forms of the conditional propositions earlier. Okay, so if you're going to identify its converse, its inverse, contrapositive, they have consistency when it comes to the truth values. That's why we have the symbol here, two-headed arrow. Unlike with the conditional that we only have one-headed arrow. Okay? For instance, a citizen is eligible to vote. A citizen is at least 18 years old. So we have here a citizen is eligible to vote if and only if he is at least 18 years old. Okay, so a citizen is eligible to vote if and only if he is at least 18 years old. Another example. You are my biological brother. We have the same parents. So if we're going to have its conditional proposition, you are my biological brother if and only if we have the same parents. Okay, we use the term if and only if. Okay, so take note of that. So for the truth values, take note again that it should have consistency when it comes to its simple proposition. So just like in the first and the fourth case, okay, both are true. So the biconditional proposition is true. Both are false. Then we can consider that the biconditional proposition is true. While in the second and third case, as you can see, there's inconsistency with its truth values. So therefore, the biconditional proposition of that is false. Okay, so take note. Again, when it comes to biconditional, again, both should be true or both should be false so that we can consider the biconditional proposition as true. Earlier, we have an example of two conditional propositions. We have its conditional propositions. If you are more than 6 years old, then you are entitled to a senior citizens card. And it's converse. Okay, if you are more entitled to a senior citizens card, then you are more than 6 years old. So as you can see here, there's consistency when it comes to the truth values. The conditional proposition and its converse is the same. Since it's the same, we can transform this into biconditional statement. Okay, we can transform this into biconditional statement. So we can have, you are more than 6 years old if and only if you are entitled to a senior citizens card. Okay, you are more than 6 years old if and only if you are entitled to a senior citizens card. Or vice versa, you are entitled to a senior citizens card if and only if you are more than 60 years old. So as you can see here, if there's consistency when it comes to conditional, it's converse, inverse, and contrapositive. When it comes to its truth values, we can transform it into a biconditional proposition. Okay, we can transform it into biconditional proposition. Okay, so take note of that. Okay, now, since we are done with all the connectives for the compound propositions, let's try to utilize them. Okay, let's try to utilize them in symbolizing the statements. Okay, so let's try to symbolize the following by using the simple statements P, today is Friday. Q, it is raining. R, I am going to a movie. S, I am not going to the basketball game. Okay, for instance, let's try to symbolize this statement. Today's Friday and it is raining. Okay, today's Friday and it is raining. So if we're going to symbolize this, we have today's Friday, that's P. We have the word end, so that's inverted V. And it is raining, so that is Q. Okay, so again, we have today's Friday, so that's P. Okay, we represent that as proposition P. And we have the word end, so we use the inverted V. And we have it is raining, so that is proposition Q. Okay, that is proposition Q. Let's have another example. It is not raining, and I am going to a movie. It is not raining, and I am going to a movie. So you can pause the video so that you can think of its symbols. Okay, so now we have these symbols for the compound proposition. So here we have it is not raining. So as you can see here, we have proposition Q, it is raining. So since this statement here is it is not, so therefore we have that negation of Q. We have that negation of Q. And we have the word end, so therefore we use the inverted V as our symbol. And we also have I am going to a movie, which is proposition R. So therefore, the symbol of that is negation of Q, inverted V, R. It is not raining and I am going to a movie. Another example. I am going to the basketball game or I am going to a movie. I am going to the basketball game or I am going to a movie. Okay, so we have here negation of S, V, R. Why? Look at this. We have the statement here, I am not going to the basketball game. But in our compound proposition, I am going. Okay, so since we have the statement here S, we're going to negate that. Okay, so we're going to have the double negation not. So that we have the statement, I am going to the basketball game. So instead of just putting S, we have the negation of S. Okay, we have the negation of S. So take note of that. Okay, not all the time that the proposition is just no, we don't have that word not. Okay, there are times that like this in proposition S we have I am not going. Okay, and its negation I am going. Okay, so take note of that. And we have the word or, so we have the symbol V, and then we have I am going to a movie, so that's R. Okay, so we have negation of S, V, R. Okay, so now let's try to have the symbol and let's construct. Okay, let's try to construct a statement. Okay, so we have Q one-headed arrow S. Q one-headed arrow S. And that is, it's a conditional proposition. So if it is raining, that's Q. If it is raining, and then our conclusion, I am not going to the basketball game. Okay, that is S. Q then S. So the statement here is if it is raining, then I am not going to the basketball game. Next one. We have another set. Okay, let's write this another set of statements. Hector will clean his room for statement A. Hector will walk the dog for B. Anthony will wash the dishes for C. Emma will cook our dinner D. And Emma will scold as E. Okay, as our representation. Okay, so given that we have the symbols B, V, C. Okay, what is the statement? Okay, so we have here Hector will walk the dog, so that is B. And then we have the symbol V, so that is or. Okay, that is or. Then we have Anthony will wash the dishes, which is proposition C. So therefore, we have Hector will walk the dog or Anthony will wash the dishes. Another example. EV negation D. EV negation D. Okay, then that symbol is either Eman will scold us or he will not cook us dinner. Okay, so Eman will scold us So that is E, right? That is E. And then we have the symbol V here so that we use or. We use the word or. And then negation D, Emma will cook our dinner for D. So if we're going to negate that, Emma will not cook us dinner. Okay, Emma will not cook us dinner. So to avoid redundancy, we put the word he. Okay, or other pronouns that you want to use for Emma. He, she. We don't know who Emma is. Okay? To avoid the redundancy when it comes to our subject. Okay, so you can put the word either, you can not. It's your choice. It's your choice to put it or not. Okay, the word either. Another example. Here, so as you can see here, it's not just two simple statements. It's more than two. So if we have more than two simple statements and we have different connectives, make sure that you're going to use grouping symbols such as parentheses. Don't forget that. Again, if you have more than two statements and there's lot of connectives. Okay, there are different connectives that is used in your statement. Don't forget. Okay, don't forget to use grouping symbols. Okay, such as the parentheses. For instance, Anthony will not wash the dishes and Hector will walk the dog or he will clean his room. Anthony will not wash the dishes and Hector will walk the dog or he will clean his room. So for this, we have the symbol. Okay, so we have negation of C. Anthony will not wash the dishes. Okay, so this one. Anthony will not wash the dishes. Okay, and we have the word O and. So as you can see, we put the inverted V. Then look at this. We have different uh, connectives. Here in this part, Hector will walk the dog or he will clean his room. We use inverted V. We use the word or. So since we use the word or, we have the V symbol. Okay, since we also have one subject, Hector, we're going to group that. Okay, we use the parentheses. Okay, B, Hector will walk the dog, or letter V. Okay, and then A, he will clean his room. Okay, and we put the parentheses. Okay, so the symbol for that is negation of C, inverted V, open parentheses, B, V, A, close parentheses. Okay? Another example. If Hector will not clean his room and will just walk the dog, then definitely Eman will scold us. If Hector will not clean his room and will just walk the dog, then definitely Eman will scold us. So you try this. You can pause the video so that you can write your answer. Okay? So the answer here is open parentheses, negation A, inverted V, B, close parentheses, one-headed arrow, E. Okay, so as you can see here, we use the word if then, right? If we use the word if then, obviously, there's a one-headed arrow here. We're going to use that one-headed arrow. And again, we have two statements for Hector. We're going to the group for the task of Hector. Hector will not clean his room, so that's negation of A. And we use the word end. We use the word end, so that's inverted V. We'll just walk the dog, that is B. Okay, then, definitely Emma will scold us. And our conclusion here is letter E. Okay, our conclusion here is letter E. So therefore, the symbol for this is open parenthesis, negation A, inverted V, B, close parenthesis, one-headed arrow, E. Okay, so again, don't forget the grouping symbols because there will be a different interpretation if we're not going to include that parentheses. Okay? Especially here when it comes to the premise and the conclusion of the conditional statement. Okay, the interpretation will be different if we're not going to put the parentheses. Okay, so take note of that.